Well, hey everybody, thanks for joining. Today we're gonna talk about extended reality, a little bit of the technology behind our studio here at Diamond View, and I'll break down a little bit of the elements of what we're using in the process that we have, and then at the very end of this we'll do some question and answers, which Gilbert will help us out with. So we'll go ahead and get started. All right. So to give you a little bit of background of View, a year and a half ago, we started getting really excited about this new technology, extended reality. And extended reality is a merge between physical and digital backgrounds. And so, here mainly what we do is short form commercial work. And so this allows us to bring in commercial product like, let's say, a sports drink or a car, and then put in a background that could be anywhere in the world, like a beach or the mountains. And from the vantage point of the viewer, they have no clue that these environments are digital. And so extended reality gives you the advantage of not having to travel and not having to pay the cost of all the logistics involved with that. So really reduces the amount of time to produce video. And we've seen it used in several verticals, from long format, and feature film, but also in short format and commercials and branded content. So I'm going to show you real quick an example of a video that we did for the Today Show. And to give you a little background on this project, during the weekend of the Super Bowl, we had the Today Show team here, and we wanted to exemplify the technology. So we created these boards, and you'll see in the left here, it starts with Kerry Sanders, who's in the Amazon rainforest, and then he's in a warehouse, and then finally he's at a mountain range, which we reveal that all of this is being done in extended reality. And so what you'll see come to life is all of these scenes done in one studio all at the same time. So take a look.
Good morning, guys. The big question is, who's going to walk away with the Vince Lombardi trophy? The Super Bowl is also about TV commercials. But this year, because of COVID, the commercials will be different. Even the way they're produced has changed.
Downloading.
This is not a warehouse. I'm in a very high-tech studio down the street from Raymond James Stadium, where they'll play the Super Bowl. Some of the commercials you'll see this big game weekend were shot in this virtual world. So real, you can't believe your eyes. Everything seems so real. Hear that? I'm in the Amazon rainforest. Well, not really. But can you tell? So again, here I am in Tampa, where there is no snow, there are no mountains, but there is, thanks to the technical teams here at Diamond View Studios. And then, boom, just like that, it's gone. A virtual world that is fast becoming mainstream in the TV commercial production industry because of the pandemic.
COVID was a big shock to our business. 80% of our work was on location. We had to find a way to do things differently. And now we can bring the location to us.
That's what they did in the making of this Mercedes-Benz commercial.
One of the scenes of the Mercedes-Benz commercial is in a garden in Italy. And imagine having to travel the entire team all the way over there just for that shot.
Action. The credit for all of this goes to video game engineers who married their technology to a huge bank of high-def TVs. There are but a handful of studios like this in the world right now. In so many ways, the pandemic has accelerated how we use technology, including making the TV commercials for the big game.
Kerry, that was amazing, right?
It blew my mind.
It was fun to watch the game, by the way, on those screens where the linebackers are like 16 feet tall. But that was incredible. You can just snap your fingers and go anywhere you want in the world.
So you'll see here in that commercial that we take the anchor of the Today Show to all these different photorealistic backgrounds, from the, you see the mountains here to the warehouse and beyond. And so what's cool about this is an industry that will become the standard of any studio shooting you'll see in the future. Some of the projections put XR over $200 billion by 2022. And so just to think about how fast this is exploding is exciting. But in just the commercial production, we're seeing that it's going to raise from 300 million now to over 700 million in the future. And so there's definitely a market for this, but it's even better as a creator, as a tool, because think about the alternative of having to shoot that same commercial. If you were to have to travel all the way to the mountains and then travel to the Amazon forest and then travel to that warehouse, it would probably take weeks for you to do. And now you can do that all in the same day. So here's some of the technology behind it. We have our own panels. They're the View panels. It's a black pixel SMD long format panel, but it's created specifically for video production. So it's optimized to be shot on camera. It has curved hardware so that it can be created in a volume geometry. And we've been able to create other technology that supports it. But really the infrastructure behind our panel is the NovaStar processing. So we use the A8S NovaStar card. And the advantage of this card is that it has full HDR capability. So we can get really high contrast, the color values out of it, up to 22-bit on the gradient for luminosity. And we've just been able to see really high performance out of this tech. The other interesting thing that we have in our volume is a translucent ceiling. And you'll notice that if you look behind me now as a checkerboard ceiling, that actually has our lighting grid above it. And so because every other pixel line is removed, it allows the light to shine directly through the panel. This also has the embedded tracking stars. And something that's unique to extended reality is, unlike shooting a normal display, which you might just play back a video, using Game Engine, you can use camera tracking to dynamically change the perspective. So as the camera moves left or right, we'd see the scene actually moves left or right with it. So really interesting technology, but several different systems working together to make this process happen. Our studio is in Tampa, Florida. It's a 10,000 square foot LED volume. And since we opened it, we've actually opened 2 more studios to support all the workload. Our configuration is a curved 220-degree wall with a flat ceiling. Portion of our ceiling is retractable, so that's on a motor system. But it's an 8K resolution screen in total, 100 feet long. And we have a motion control robot called the Bolt, which allows us to do precise movements inside the volume. So here's a little look at it. And you'll see in the center there, that's the retractable portion of the screen. So whenever it's up, it's seamless, like it is now. And then whenever it's down, we can do things like close reflections, make more immersive environmental lighting. There's a lot of advantages to be able to lower that screen. These are some of the tech partners that we use. On the lighting side, Aperture for camera tracking, Moses for the game engine, Unreal Engine for the camera movements, Mark Roberts motion control for the graphics performance, NVIDIA, and for all of our processing and the LED panel management, we're using NovaStar. So I want to dive into a little bit of the NovaStar technology. So on our panels, we are doing long format with the A8S again. And some of the best things about this is the HDR, but also a new feature release called Clearview. And Clearview is essentially a digital anti-moire function. So what it does is when you're looking at the screen, if you get a camera too close, you could get an effect called moire, which would really take out the optical illusion that we're actually there. And Clearview allows you to smooth that. So in addition to HDR, you also have that on these. Our panels are equipped with the ultra black technology, and essentially between each pixel, when you talk about pixel pitch, that is the distance between the center of one pixel to the center of the other pixel. Pixel gap is the distance between the edge of a pixel to the edge of the other pixel. In a wider pixel gap, you have matting on it. And the matting is important because how black you can make that matting determines how high your contrast ratio can be. And then the other thing that determines that is the actual pixel covering. So in a standard outdoor pixel, you would use a white pixel, which is much brighter. A lot of times it's IP65, so it's weather resistant. But in an indoor panel that's optimized for virtual production, you'd use a black pixel, and we use an ultra black pixel for our panels. The color uniformity across panels is really important because as you pan across the scene, you don't want any difference in luminosity or color rendering. And so what's really nice about the NovaStar processing is that you can go in with programs like CalMan and calibrate all the way across the screen to get perfect uniformity. So this is something that even if you have different batch panels, different technology in the processing for the cards, using NovaStar allows you to really get that uniformity on a whole nother level. Another thing that we've done with our wall is if you use a flat panel with curved hardware, you really increase your ability to change the curve across the wall. And one thing that we found is when you create a large curved wall, like an LED volume, what you essentially do is you're creating the parabolic effect. And the parabolic effect is anytime you build something that's the shape of a drum, it amplifies the sound. And so all the acoustics really resonate. The problem with this is if you're doing a scene that's out on the moon, you don't really want it to sound echoey. You don't want it to sound like it's in a theater or some kind of a dome. And so it's important that you vary the angle of the wall every other couple of tiles. And what I mean by that is if you were doing a 100-foot wall and you're doing a 180-degree curve, you would set the hardware at somewhere around 3 degrees to make that happen. If you do that consistently across, you'll get that that reflectivity from the parabolic effect. However, if your hardware is adjustable to the 1/2 degree, that you could go 3 degrees, 2.5 degrees, 3 degrees, 2 degrees, 2.5 degrees, that variability of the wall won't be able to be seen with your eye, but it'll reduce the effect of the acoustics. And so that's something that we've found out building these, that it's important to slightly vary the wall as you go around. Now, like I was talking about before, our ceiling tiles are very unique in the sense that we're using a transparent panel, so every other pixel line is removed. But we've also patented the approach of putting in a tracking IR star into the panel. And so you'll see here, this is a very close-up shot of an IR star into a 3.9 panel. So we 3D print these stars and then laser cut them around the LED diodes so they don't obscure any of the image. And this allows you to track anywhere in the volume. And the reason why we use MOSIS, which is a tracking method, is because by using this, you don't have to do an outside-in solution. So if you're not familiar with MOSIS, MOSIS is an infrared star tracker-based system. And so the tracker or the reader is on top of the camera, and it points directly in the air. It's an infrared reader. And so these stars are assembled in a star constellation all on the ceiling. When the reader looks at the star constellation, it can triangulate its position in 3D space. And so that's important because now you have a very reliable tracking solution anywhere you're at in the volume. If you use a standard LED ceiling tile, then when you get underneath that ceiling tile, you don't have any tracking because it has no reference points. So by using this solution, we are now able to walk into the volume and out of the volume and get tracking all the way throughout. Now, if you don't use an LED ceiling, you could put the tracking stars directly on the roof of the room and get the tracking. But the advantage to having a ceiling is that if you're shooting any product that's reflective, it'll actually reflect the ceiling. And then you can also use the ceiling for environmental lighting to get a more immersive effect. And so here's a little bit about how the NovaStar XR system works. Your video source can come from a computer, a camera, any kind of playback device, HDMI, SDI, DisplayPort, but it ultimately goes into a processor. And we use the H9 processor, which is one of the mega processors for NovaStar. It can do up to 40 million pixel load. But here in this image, we see that the M-Control 4K is being used. And what that does is it takes the incoming video signal and puts it to all of the LED receiving cards as a single image. And this setup process takes about an hour for you to take the processor and assign the image across the cabinets. But a cool thing about the M-Control 4K and the A8S or the A10S receiving cards is that gives you that full HDR ability, 22-bit color, and then a really precise grayscale. And another thing is Gen lock. It's very important that your output system and your processor are Gen locked together so that you don't have any tearing on screen, and that happens when two image sources are at different rates. So what we're looking at here is 22-bit grayscale. And this illustration below shows you what banding looks like when you have a grayscale issue. So typically on an 8-bit system, there's not enough luminosity shelves to actually create a smooth gradient. So what you get are these steps. And so you'll see on the bottom right, the grayscale steps. Now, if you have more grayscale, there's less steps, and so it reduces this image. So you'll see that blue line actually showing how many steps are in a 22-bit versus an 8-bit. And this is very important because not only are the steps giving you more range of luminosity, but it's giving you a smooth gradient throughout. And so what you're seeing here with the RGB is that each of these steps are affected by the luminosity scale there. One of the really important things with any LED system is making sure that the color management is optimized for the camera. And so you'll see the color science here behind NovaStar is that you can have several different color modes. You can be in 2020, you could be in Rec 709, you could be in DCI P3. So really, depending on what your use case is, you can change your screen to have those different color sciences. I'm going to show you here a commercial that we did for Mercedes-Benz, and all of this is shot in front of the LED screen, so you can get a reference for how this color management looks on camera.
What drives a leader? For 135 years, there's only been one inventor of the car. For generations, no one has been reinventing it again and again, like Mercedes-Benz. And for decades, one car has led the brand that's led the industry. This is the S-Class, with innovations that redefine what a car can do and challenging every other car to follow its lead. With luxuries like you've never experienced, but will soon realize you can't live without. And with design that's the forefront of fashion, yet never fails to become timeless. It's majestic, yet understated, stately, but slips through the wind, where state-of-the-art becomes fine art. In a cabin that's all digital, yet highly handcrafted. 3D and organic LED screens are surrounded by natural woodwork, expansive in dimensions, exquisite in detail. The finely tailored leathers, the work of 16,000 needles in unison, matched by eye and fitted by hand. It all comes together like no other car. Perfect fit for today and tomorrow.
So you'll see in this commercial here, we're using several different scenes, driving scenes, the opening shot of the tailor shop. And so in this behind the scenes here, you'll get to see how all that came together with the volume surrounding the car to really get these immersive reflections. And so you'll see the interface there for Unreal Engine, which is the gaming engine that runs this. It's mapped to the geometry of the screen. And so as the camera's moving around, we're actually seeing the perspective shifting on all these. The camera control we're using here is the Agito, and that's a robotic control RC car. Allows us to dolly very quickly on this. But again, the effect of the entire commercial is all done in extended reality on LED volume. So really new revolutionary way to shoot. So another feature here of the A8S is frame multiplication. And what this does is it allows you to multiply frames throughout a single refresh. And so if your source is 24p, you can now, push something that's more like a 60p type of image. It basically multiplies the frames in between the frames to give you a smoother image rendering. Genlock reduces the tearing and also reduces any of the banding that you might see of a normal refresh on the screen. And one thing that's a common misunderstanding is that you need to genlock all of your systems in order for the effect to work. We found that by genlocking your source computer, and if you have any render nodes, you'd have to genlock all of the render nodes, but genlocking that with the processor is sufficient to be able to do a normal shoot in LED volume. So not having to genlock the camera as well, most times with the frame blending and everything being genlocked on the input source side, the need for genlock on the camera side, you don't need to have that there. One of the other things is HFR. HFR is the high frame rate ability. You'll see here on the left, 60 hertz, we get a lot of motion blur. But on the right, it's being solved for by that same frame blending. And so now I'd love to open it up to question and answer, and happy to answer anything that you have questions on. Gilbert, did you want to start us off?
I saw the chat window have 2 questions. It's related to the LED panels.
Uh-huh.
So I think you can answer these 2 questions. It's about the peak white and also the outside content being created. It's about the XR stage.
Okay. Yeah, I'm seeing them in the chat now. So the peak white is 1200 nits for the black pixel. So that is our wall unit here. And then for the ceiling, it's either 3500 or 4500 nits. And the difference is that's a white pixel outdoor LED. Right now you can see the ceiling, it's about 10%. So it's low brightness, but that can go quite a bit brighter. What codecs are outside contents being based on? So that's a good question. There's 2 ways to do content. One is through Game Engine, which would allow you to stream it raw directly out of the Game Engine. So there's not a codec for that. But if you're going to do video playback, we use ProRes 422. And it really depends on what playback software you're using. You could use something like Arena Resolume, and that's a playback software that does multi-screen playback. You could also use a software called QLab, and depending on what software you use, you might change your codec for that. So on our softwares that we're using ProRes 422. Yep, 1200 nits. And then it says allow, how do you preserve HDR with only 1200 nits? Well, the big function of HDR is that if you are to reduce the brightness on your screen, you could still have the full range of contrast. And so consider this, behind me, there's 360 long format modules on the wall and about 200 on the ceiling. Because of how many there are, it's extremely bright. And so we run our wall at about 50% brightness. If you have a SDR source, what happens is you've now cut down your contrast ratio. So at 50% brightness with HDR, it allows us to have the full gamut of contrast still. And I think that's something that you might see with your walls. Even though you get a panel that can perform at 1200 nits, 1600 nits, 2000 nits, you will likely, depending on how large it is, not be running at 100% all the time. The electrical load of this wall is 350,000 watts. So we're very rarely ever pulling more than 80,000 watts with what we're running. Yep, we're using the Nation Star driving IC, and the scan rate of this wall is 1/16. And I'm seeing all your questions in the chat, so feel free to throw them in there and I can answer any of them. I don't know the MBI model. I can get that to you though. So question is, the M-Control 4K can input signal at 60 hertz. How do you achieve 144 frames per second? So the way you do that is through the frame multiplication. So it allows to build in more frames throughout the playback. And then the next question on here is the ghost frame. So ghost frame is essentially multiplexing. When you multiplex, you're taking frames in between the frames and putting another image on it. This is something that the processors don't currently do, but they have the capabilities of. So I wouldn't be surprised if in the future that feature comes out, even on the current models, because if you think about it, the frame multiplication is doing multiplexing because it's taking the frame before and putting it in the middle between those two frames, and that's essentially what ghost frame is. It's just doing that with a different input source. No, so there's a couple of things going on here. So the question is, with high frame rate, do you have to sacrifice your total output resolution for the bandwidth? The way that the processing works on the receiving card side and the sending card side is that if you make your maximum path for data, like on 3.9, you can go 20 panels. You can daisy chain data across 20 panels. If you do that, then for modes like HDR and Clearview, it won't work. You have to reduce the amount of data run. So if you take it now to 10 panels, now there's less processing from the processor and the receiving cards. And so you can do those functions. The same thing here with HFR. It's all about how many total data run you're doing. And so by reducing that, it'll allow you to get that feature. So 2 ways to do this. The question is, any options for tracked color gamut based on camera location? And then what about off-axis color correction? So for us, if you notice, the ceiling is an off-axis panel. And so we color correct that globally. We do that on the processor side. And so we know that no matter where the camera is in space, it'll always be off-axis for us. So we color tint that in advance globally. For the dynamic color changing, what we do is in Unreal Engine, the field of view is in what's called the frustum, and the frustum is a moving box that's in the background. And since you know that the camera source will never see outside of the box, we use the outside of the screen to do all of our environmental lighting. And so we'll often overexpose the outside of the frustum in order to get environmental lighting. So that is an example of a color correction that's happening outside, but it's for the purpose of environmental lighting, not necessarily for shifting the color. Another thing I should note is that you have several options on how to set up an extended reality studio. are options mainly for commercial, cinematic, feature film type applications. And so it's a large volume, but you'll also see 3-wall solutions. And 3-wall solutions typically consist of a floor, LED floor, and 2 walls that are at 90 degrees. And so if you shoot into that at a 45-degree angle, then you can dynamically change the perspective across those. And that's where that color shift is a little more important. So question is, have you done any real-time production with live or live to tape without post-editing using this tech? And yes, we have. In fact, last Thursday, we had a live stream where there was several presenters. They came on stage right in front of the screen, and we were able to play their presentations, do dynamic contact playback, and the record from the cameras that was watching the event went out to a live audience in a similar platform like Zoom. And so, you know, it's very reliable. People are using this type of technology for live events all the time. So good question here, low latency mode. We've connected our wall in vertical modes, but are noticing errors with high motion. Is this a feature that could be used for virtual production, the A8S cards? Yeah, so A8S and A10S both have a feature called low latency mode, and low latency mode allows you to do a 0 buffer. And so typically a processor will take the input signal, buffer it, and then send it all out as once. With low latency mode, we're skipping that process, sending the data as fast as it can. And a lot of times the latency will be seen on the tail of the train. So if the data train goes out, it's the very last part that's still processing that gets possibly a frame skip or any low latency. So now with this low latency mode, we're 0 buffer straight to the card, and the card, because it's a much better high processing card, can take the data in just like that. So we're shaving off milliseconds that are very, in a real-time environment, are very important for playback. So notice that the top panels are out of frame. So this right here. So this is the front of our volume. So this is what it's called, the mouth. And I'll show you all the way around. So we have that empty because we actually have our lights. So if you'll see it right here, these are all of our lights above. And so we've actually taken out that portion of the ceiling, mainly to do key lighting. Oh, I see what you're saying. So the top panels of your LED setup are, maybe explain that a little better. They're out of sync. Well, there could be several things. You know, one could be that you're running too many on a single data line, which I'd recommend trying to put that on a separate data chain. You know, if you exceed the amount of data, so 7 tall, how are you configuring that? Are you vertically chaining them together? Okay, and are you doing it just in 7 or are you doing 14, 21? What's your pixel pitch? (192), so 2.5. And the standard format panels, so 500 millimeters by 500 millimeters. Okay. So there could be a couple things going on there. I mean, that's not too much data. What I would try to do first is to reduce that down to 6 and see that if at 6 panels, if your sync comes back. If not, the next step would be, you know, to try to even reorient the path of the data to see if possibly there's a dirty connection either on top or bottom. But you know, without seeing it, there's several ways to diagnose it. I would say that if the rest of the board is doing good, it's probably not a sending processor error. And if you're still getting you know, good quality signal, then it's probably not a receiving card. It's probably a data line error. So how that data is actually run. What's your total amount of panels? So you have 7 vertically. How many panels wide? Over 2 processors. And you're using the M control 4K? Okay. Well, here's one thing you could try, is that the H series processor allows you to do the same functionality, but in a single processor. We're doing the wall here and the ceiling all on a single processor. It's possible that instead of chaining the processors by doing a single processor, that you might reduce that effect you're seeing. Again, there's a lot of variables in what could cause that. So to diagnose it, you'd have to look at several things. Any other questions from the group? Well, Gilbert, do you have anything else?
Yeah, actually, I want to make a little addition about 3 questions about. The first one is about the MCDR 4K, how we achieved 144 hertz for the refresh frame rate. Actually, we got a customized firmware to support the 144 hertz high frame rate. So if you want to use the 144 hertz frame rate, you can just contact us. We can send you guys the customized firmware. So this is the first question. And second question is about the high frame rate have some sacrifice. Yes, it has some sacrifice because the total bandwidth, there's no change from total bandwidth. So if you use the 144 hertz high frame rate, the loading capacity will be reduced racially, So for the 60 hertz, the loading capacity for each port is 650,000 pixels. But if you use 144 hertz, it will be reduced to like less than half of this. So this is the second question. And the last question about the low latency mode, and you can see some sync problems on the screen, right? So I think maybe it's related to the firmware of the receiving cards, because some of the customized receiving card cannot support the low latency features. Some of them can support. So you can check the firmware of the receiving cards, see if they have the same firmware version. Yeah, this is another factor. Yeah. Okay, that's it. Thank you.
Great. Well, any other questions? Well, thank you all. And Gilbert, unless you have anything else, I think we're good. And I can give you just a quick look around here. Oh, here we go. Gilbert, I'll let you answer that one.
Okay. For the 144 hertz, the source is it's come from, some computer, the high-end computer GPU can output that frame rate directly. And also some of the video processors can output the high frame rate as well. So graphic cards or the video processors.
So I'm going to give you a quick look around here of the studio so you can kind of see the setup. So our stage is right here. We have a portion of the ceiling that's retractable. So this whole section can come all the way down to the ground. And what we're seeing right now is an environment that's an Unreal Engine. And you'll see the the amount of contrast here. I mean, even as this webcam gets closer and closer, you know, it's still doing a good job with not getting any moire from this. And then if you look up, you'll notice that this is the star constellation. All the little dots on the ceiling there are the tracking points for the MOSIS system. And so we do all of our processing back here. This is our brain bar. And so the computer systems for Unreal and the lighting and everything are here. And then in other parts of the studio, we have where we keep the gear, and then this is the back of the volume itself. And so you'll see the configuration. What's really unique about this is very large wall, but we only have a few supports. And the reason why is when you build something like this into a cylinder, it becomes self-structural. So the panels are bolted together with this. So they're not just the quick connections, but they're also this hardware that actually creates the structure for it. So what you're seeing with the truss is really just a sway bar, but all of the support is in the wall itself. And so if you're looking to do an LED volume, you know, it'll likely have a support system based on what the radius is, similar to this, but we found that you know, just with the very few supports, it's very structural. And then to show you a little bit of our other studios, this is our product studio. So we have a Bolt, that's the motion control robot. And then we have a small screen here. So this is a 14-foot by 26-foot screen. And when we're doing any kind of product, we'll put the product here and we'll do the motion control robot all the way up to the product. And this allows us to take the motion tracking from the robot through Unreal Engine to the screen. And so you'll see this is like a bar scene here that we were doing some of the like a beer commercial with earlier in the day. So there's a better look at it. One thing that's unique about here is with the motion control robot, if you lay it directly on the floor, it could make the screen vibrate. And so we've actually cut the floor out and inserted the track into the floor with these rubber siders so that it doesn't make anything vibrate in here. And here again is the look at the back of the volume. 350,000 watts, 16,000 pounds, all P3.9 on here. And again, the reason why we did 3.9 here and 2.9 there is the distance that you're shooting at here is never within about 20 feet. And so with 3.9, it still looks very high resolution from that distance. So if you were shooting much closer, like 10 feet, you know, you'd probably want to be in the 2.5. And if you're shooting under 10 feet, you might be in the 1.9 or 1.5 range. So important things to think about when you're getting the right LED for it. What is your failure rate? Well, we've been running this volume for about 7 months, and out of 360 cabinets, which is 720 standard size, which is ×4 for the modules. So 2,800 modules. We've had 2 bad modules. So 2 out of 2,800 in 6 months. And you know, the important thing to do is get same batch replacements. Because we had one, they never typically fail completely. You'll start seeing like a blue line or a yellow line. But if you get a bad pixel or you get bad data on it, you'll want to make sure that you swap it with the same batch and the same batch that's been calibrated to it. So we've been fortunate that we haven't had much failures. I'll tell you where you see a lot more failures. I just showed you a studio with 2.9 in it. We have a 1.9 screen, and the 1.9, because the pixels are so close on the edge of the modules, they're very fragile and they break very easily. So you see a lot more failures with 1.9. 3.9 is very, very sturdy because there's so much more cushion. So I've been really happy with the 3.9 product. Cool. Any final questions? I know we're getting close to time here. All right. Well, thank you all for tuning in. Gilbert, do you have any final words?
No, I think I'm good. Thank you.
Okay. All right. Well, thank you all. Have a good one.